In this video I want to go over the homework problems that were assigned from our Larson text, Chapter 2, Section 2 and 3. And here we want to use the rules of differentiation to find the derivative of each function. So problem number 3 is an example of the constant rule. Remember, a constant is a horizontal line. Its slope is 0 everywhere. So we can simply state that y prime is equal to 0. Number 5 is an example of the power rule. And here we're going to bring down the 7, multiply by x, reduce the exponent from 7 to 6. With problem number 7, we also have a power rule, but we're going to rewrite this first. And we're going to write it as x to the negative fifth. Then we apply the power rule by bringing down the negative 5, multiplying by x, reducing the exponent from negative 5 to negative 6, which can also be written as negative 5 over x to the sixth. Alright, following this, number 9, we have the fifth root of x, which we will also use with the power rule after we rewrite. And recall that the fifth root of x is the same as x to the 1/5 power, and we'll simply bring down the 1/5, multiply times x, then reduce 1/5 by 1, so that's 1/5 minus 5/5, or negative 4/5. Simplifying that, we'd get 1 over 5 x to the 4/5. Now problem 11 is an example of the sum or difference rule, together with the power rule and the constant rule. So the derivative of x, we treat that as x to the first power. We bring down the 1, reduce the exponent from 1 to 0, and x to the 0 power is 1, plus 0, because the derivative of 11 is 0, and that just leaves 1. And that should make sense because problem number 11 is a linear function and it has a slope of 1, therefore its derivative is 1 everywhere. With problem 17, again, we have the sum or difference rule together with the constant multiple rule. So the sum or difference rule tells us to take the derivative of each piece, and if any of those coefficients are greater than 1, for example 5 times t squared, we're simply going to multiply the result by 5. So let's see what that means. So s prime of t is 3t squared, and that's just the power rule. Then we have 5t squared, and the derivative of 5t squared is we bring down the 2, multiply times 5t, and reduce the exponent to 1. That's an example of the constant multiple rule. And finally, the derivative of negative 3t, we treat that as negative 3t to the first power. So we bring down the 1, multiplied by 3 times t to the 0 power. And finally, the derivative of 8 is 0. Then we can simplify that to get 3t squared plus 10t minus 3. And you could have gone right to that point without doing the intermediary steps there. Now we basically covered all of the fundamental rules here. The constant rule, the power rule, the sum or difference rule, the constant multiple rule. And now we have the trigonometric functions sine of theta and cosine of theta. Well, remember the derivative of sine of theta is cosine theta. And so pi over 2 sine theta will use the constant multiple rule. So the derivative of pi over 2 sine theta is pi over 2 cosine theta. The derivative of cosine theta is negative sine theta, so the derivative of negative cosine theta is positive sine theta. And so I skipped a step in there. Number 21 is a power rule and trig rules. So we'll say that y prime is equal to 2x. Then we have the derivative of 1/2 cosine of x. So that'll be minus 1/2, and then the derivative of cosine x is negative sine x. And so when we simplify, we'll have 2x plus 1/2 sine x, since the two negatives will become positive. For number 23, we'll rewrite 1 over x is x to the negative 1 minus 3 sine of x. For x to the negative 1, we'll use the power rule. So we bring down the negative 1, reduce the exponent by 1, that's x to the negative second. Then the derivative of sine is cosine, so we get negative 3 sine x. And that does it for this video.